What if robots could truly see? Not just follow lines or sensors, but understand their surroundings, recognize humans, and navigate safety on their own. In his story, Przemysław Zakrzewski, Vice President at ABB Mobility, will reveal how ABB integrates 7sense Robotics visual SLAM technology with autonomous mobile robots. This innovation allows robots to navigate complex environments, from factories to logistics centers, with precision, safety, and true autonomy. Please welcome Przemysław Zakrzewski.
Good morning. Still, do you want the full-blown PowerPoint or maybe 4 slides only? What do you prefer? Just raise your hand. Short version on short? No, long. Okay, so then I will keep long. Okay. So my name is Przemek. I'm going to talk a little bit about seeing with AI, and I would love to refer to a couple of things we already mentioned. What this meeting is about linking innovation, academia, business, a little bit also solutions, and then the very first question at the beginning was, what is the next step? Can we predict a little bit? So I tried to include all those things in my small presentation. So ABB, for those who don't know, it's already 130 years innovation, but maybe one thing out of plenty of different activities related to AI, data centers, the hyper-scalable computing environment. Recently, we just announced a couple of days ago, we and NVIDIA, we're gonna develop technology for 800 DC supply to 1 megawatt racks for servers in data centers together with NVIDIA. So which is a next step of energy efficiency. So if you want you guys to remember what ABB is about, it's like, making the energy efficiency on the next level. Collaboration. So I'm here because of plenty of people working as 7 research centers across the globe for ABB. So I'm just only the front face to a couple of colleagues who are developing the technology, and we are super proud because it's been already almost 30 years when we collaborate across with Swiss, Germany, Sweden, and China, India, and of course US. And then talking about this local environment, and believe what we are meeting here, we truly believe at ABB that collaboration with university is the step for innovation. So that's why we put a lot of attention to different type of activities. I just put it couple of academia we collaborate with, and then over the last 27 years, it's been already almost 1,500 different type of papers on innovation, on patents, etc. So that's something that the question is, if you can help me to make it bigger. So that's why I'm super happy to be here. And then we contribute really to Polish science, so that's why we already 21st years that we have a ABB award for the best PhD thesis. So we have like 50 plus universities collaborating with us on different type of technology, not only AI, if I can say this way. Okay, then let me a little bit push you in the out of comfort zone. So this is not my picture, I took it from internet. So as you can see here, it's like between the AlexNet, which is potentially the milestone of the modern AI. So if you look at from AlexNet, that was developed as a hackathon in California. And then if you look at the modern AI, it's like 15 years span between development of different type of models. And then the question usually I ask, I didn't hear today, I haven't heard, the technology pace development is so crazy, it's never been like this. So then I put together this slide, talking about the 15 years, when you start with the first flight, like the 33 meters, 20 seconds, the first flight. And then if you look at the 15-ish years later, 16 years later, we could fly across the ocean. So is it really technology changing today very, very fast? Or maybe it used to be already like this. So, and one of the things Marek mentioned today, how we measure technology development and the pace, it's about the number of GPUs or the impact on the social environment. Then can you imagine 15 years, You just stand still on the ground, and then 15 years later, you can fly to US from Europe. So it was huge change. So that's maybe another metric we need to apply to what we want to do together with values, etc. What Marek already mentioned, I'm super happy with the statement. One thing I just wanted also is not only about the progress of technology, but also agreement between different type of companies on the common approach to, like LTE. Thanks to LTE, we could change the technology from TV, watching TV and using smartphones within like maybe 1.5 years, when we totally switch our attitude, what kind of devices we use and how we use them. So it's really a couple of things together. Okay, going slowly to the topic about seeing with AI. So definitely the multimodal AI model, this is something that brought us to this point, so I don't need to explain, I believe. Maybe a little bit embodied AI. Maybe if you follow a little bit ABB, recently we also said physical AI. This is something what we want to do together with our robots. That's why we already closed the deal with SoftBank. Then SoftBank is saying, okay, we can take your robots ABB and then we can bring it to physical AI closer. So that's one of the message. And then there are a couple of things that we need to pay attention to different boxes, how the technology needs to develop in order to make it really closer to this physical AI. But this is the statistics I took from Stanford University report from beginning of this year, and there is a number of different type of machine learning models developed by academia and industry itself. So as you can see, this is one of the picture from US actually. I believe this is very based US data. So it seems that we, industry, we are a little bit, creating a gap between what we do together with a university. So that's one of the messages I wanted to share with you. Maybe we need to pay attention more a bit as a business, how we deal with universities and in terms of innovation and development. So this is McKinsey, a little bit. Maybe I was trying to answer the question, what is the next? Really something what we can predict, foreseen in the short-term perspective. So definitely this is the logistic type of, like from when you transfer one good to another one. Right now you have a transfer hub, so manual work done here, and then you transfer it again manual. So I believe that in the very near future we're saying a destination to destination, it's like fully autonomous thing. Yeah? So that's a little bit of the vision I believe we believe also in. There are plenty of different type of robots and areas of technology development we need to focus on. Just to give you, like, for example, power source that can be fitted to a robot, or maybe the material the robot is made of is super important as well. If you look at the collaboration robots and the way how you can touch them, you can interact them, it's important elements. And it's on AI as well. I have a movie as well, as other colleagues. It may look like a typical sales and marketing movie, isn't it? But I'm not sure if you noticed, there are 3 elements that are super exciting from research and development. First of all, I'm not sure if you noticed, camera, just taking pictures, and then we had a number of different cameras. So this is the message what we move to the market. Right now, the technology and the barrier of entering into robotics, autonomous robotics, is getting lower and lower. Like you can take whatever camera you have right now, and they can plug into the system that can. And then there is a second point: the picture taken, and then from the picture, or a couple of pictures, you can map actually 3D dimensional space around you. You can feel it, you can see it already. So this is another thing in this movie. The third one, I'm not sure if you noticed, but also the lady, she was like, moving the finger and showing to robot how in the 3D space the robot needs to behave. So there is no, and then a little bit colorated thing with this one. Was like, if you have a kids or maybe you play Minecraft, you know how you program Minecraft game, just blocks. You put the block, you link them together, etc. So this is the idea. You just point the robot. This is how you need to behave. And then the program automatically is created, executed, and then, of course, optimize it later, depending on the application, depending on the needs. So with this 1 minute movie, I believe that we already included the number of trends and mega trends. We pushing our solutions more to the physical AI. So with simple thing. I don't want to bother you very much with me, maybe 2 more slides. So just to tell you that we believe collaboration with universities. This is a great example, like our colleagues from 7 Sense Robotics, ABB, decided to 2023 to invest in this startup, which originated with ETH Zurich. So that's super, I believe, excited that, as a spin-off from academia, we can embed it in our solutions. So that's a little bit history, how this mobile robot look like. It's still, if you go to some shop floors, this still exists, like, the normal automated guided vehicle with lines, sensor, beacons, whatever you use right now. But we push together with our colleagues from 7 Sense a little bit from autonomous mobile robot. And then autonomous mobile robot is like focusing on sensing, localization, obstacle. The rest thing is a little bit out of the scope. For different solutions, we focus very much on manufacturing and logistics. Then just to give you, there's a huge space in terms of investing and why we should develop this technology for different business area, but also for different drivers like labor shortage. Maybe this one is also important because we already mentioned today, like human needs to stay as a value, as the human who drives everything. So then we say, but labor shortage also shows us that there are plenty of tasks people don't want to perform, just simple like that, yeah? Because it is boring, maybe dangerous for us, etc. So that's why we see also opportunity in this area. Maybe the last thing, I don't want to maybe talk about the details about technology, but the beauty of this solution is it's first of all, again, simple picture, but if you look at the cameras, because we're talking about our robots seeing only with camera, no radar, no lidar. We don't believe the radar and lidar is the future, so we say only pictures. Taken pictures, and then out of picture we can actually make a lot. So camera is the one thing. The computing device itself is super important element in terms of how we embed software with algorithms here, etc., as a disconnected totally world. And then, last but not least, the connectivity between cameras and this device is super fast, super important, reliability, maintainability, etc. So again, simple picture, but if you look at the future, it's super important. And then for you, you already showed a couple of very similar pictures. I don't want to repeat them, but usually we say out of, you take a picture, this is a logistic floor. Then through a special algorithm, you just discover a couple of characteristic points in your environment, and then you base on them at this stage. But then having those things, and then if you link them together with, I have here the name, integrated measurement units. So the speed, the acceleration, the angle of the robot. If you fuse all those things together, you can create actually the 3D maps of your environment. And then if you have a map of an environment, then you can go from the edge disconnected device into the swarm of robots working together, sending information to each other, informing, getting information outside the world. So then you put everything together and you have a beautiful ABB solutions together with university developed. So thank you very much for this quick use case.